In this experiment, you're going to be measuring the moment of inertia of 3 different objects 2 ways. So you're going to be measuring the moment of inertia of 2-point masses, of a disk, and a ring. Now, the first way you're going to be measuring the moment of inertia is just using the definition of the moment of inertia. The moment of inertia is equal to the integral of r squared dm. Now, in your lab manual, this calculation has been done for your disk. You're going to need to do it for the 2-point masses and for the ring. For the disk, we get the relationship I disk is equal to a half mr squared. So once you've got this relationship, you're going to take the required measurements to work out your moment of inertia with an uncertainty. So for our ring, you need to know its mass, so you'll put it on some scales and get the mass. You also need to know its radius, so you can measure its radius or its diameter and divide it by 2 with the vernier calipers, which are provided for this task. Now, the second way you're going to measure the moment of inertia for each of these objects is using the relationship that the moment of inertia is equal to the torque divided by the angular acceleration. And as I'm sure you remember, torque is equal to r cross F, where r is the distance from the pivot point and F is the applied force. So in this case, you're going to be applying a force from hanging masses, and so the applied force will just be the mg of those hanging masses, and you'll be applying it about a pulley, and so the r here is going to be the radius of that pulley. So what you'll be using is a rotary motion sensor, which will track the rotational movement of the disk as the mass drops, and from those measurements with the rotary motion sensor, you'll be able to work out what alpha, the angular acceleration, is. Okay, let me show you how to set up the equipment now. So to set this experiment up, what you're going to need to do is start by screwing the object that you're going to measure onto the top of the rotary motion sensor. So there's a screw provided for this. Just pass it through the object and screw it into the rotary motion sensor. Then when this rotates, it will rotate something inside the rotary motion sensor, and that will be detected by the computer. Now, there's 2 pulleys involved in this experiment. Underneath here, we've got what's called a 3-step pulley. And for this experiment, it works best if you use the middle one of these steps here. So carefully wind the thread around the middle pulley. What you'll be doing then is hanging the thread over this ultra pulley and applying the weight force downwards with a hanging mass. So it's really important that the string travels at a tangent from the middle of this 3-step pulley to the ultra pulley. So you've got some screws here that allow you to adjust the angle of the ultra pulley. So carefully adjust that so that the string is traveling with a perfect tangent. What you'll do then is you'll hang your mass for the disc. We want the 15 grams, the 5 grams on the 10 grams on the 5 gram mass hanger. And once you're ready to collect the data, I'll show you how to set that up in a minute. You just let go and the computer will record the angular acceleration as it drops. Okay, let's look at how to set up the Logger Pro now. In this experiment, you're going to be using this Lab Pro to collect data from the rotary motion sensor and send it to the computer. So the Lab Pro requires 3 different inputs. It requires power, so you have a power cable that you need to plug in. It also needs to be connected to the computer with a USB cable to send that data to the computer. So So when you're plugging it in, be careful with this cable. The picture goes on the bottom, so look at the shapes carefully and make sure that you match them up. Please don't jam them because this breaks the equipment and it is fairly expensive. So that's plugged in at the USB port on the back of the computer. And then I need to plug in this rotary motion sensor. This goes into the DigSonic channel, so it doesn't matter, you can do it into 1 or 2. I'm going to do it into 1, so it should just click in. Again, please don't force it. If you're trying to plug it into channel 1, it's not going to work. Don't force it. Try the other one, and if you need any help, just ask your demonstrator. Okay, so now it's connected to this Logger Pro. Now I need to set up the right software on the computer. So I should have this experiments folder on the desktop. Inside the experiments folder, there's a folder called Logger Pro Experiments. This is using the Logger Pro, so this is where I'll find my moment of inertia experiment. So there's a moment of inertia template here, which I can open up. And it's now detecting this rotary motion sensor. If I move this at all, you can see it's changing the angle. So up the top here, I've got a graph of angle versus time, and down the bottom, I've got angular velocity measured in radians per second versus time. So when I'm ready to collect the data, I'm going to hit the little green play button at the top of the screen here, and that'll collect data. So let's have a look at what that looks like. As you'll be working in pairs, have one person let go of the weight while another person hits the collect button. You can stop it as soon as the mass gets to the bottom. It's a good idea to try and catch the mass before it hits the floor so that it doesn't get all tangled up. Okay, now we're ready to analyze our results. It's a good idea to hit this A button, which is auto scale, and that will blow it up to hit the whole screen. Now, what you need to know about is the angular acceleration as the mass was falling. So the angular acceleration is going to be the gradient of this velocity time graph. So in order to find out what that gradient is, we can highlight that part of the graph where it was dropping and it's a nice straight line. And then we can tell the computer to do a linear fit here. So that will tell us what the linear fit is, and it tells me what my slope was. In my case, it's minus 17.93 radians per second per second. So you'll record that value in your lab manual, and then you'll need to repeat this experiment at least twice so that you've got 3 measurements for each of those different objects to allow you to calculate an uncertainty. So good luck with this experiment. I hope that it teaches you a lot about rotational inertia.